Alright, lesson 6.3 today. We're going to teach you another way or another strategy to do integration. This is called integration by parts. So when do we actually use integration by parts? Well, the answer is when substitution doesn't work, inverse trig doesn't work, separation variable doesn't work. This method allows us to integrate products. Okay, so two things multiplied together of algebraic and transcendental functions. So once again, transcendentals are things that are not polynomials, like trig functions, exponential, logarithms, that kind of stuff. Okay. Now you think about when we had the derivative, there was product rule. Integration by parts is like the integrals product rule. Now, how do we figure this out? Well, remember the derivative of two things multiplied together. In this case, I'll call them u and v. Yeah, thinking product rule, it's like the first function u times the second function v prime, or I'll use dv dx. And then you're taking that and adding it to the second function times du dx. Wow, product rule, when was that? That was like unit 2 or unit 1, long time ago. So now my question is, well, what happens if we were to take the integral of everything? So if I take the integral of the derivative of uv, and of course I'll use dx, and if I take the integral of u times dv dx, and then I integrate v du dx, what am I left with? Well, on the left side, the derivative and integral, they're inverse functions, so they just cancel out, so you get just uv. And on the right side, I get the integral of u, and notice the dx is kind of cancel out, so that's u times dv. And then I have here plus the integral of v times du. And so now what I'm saying is, if I asked you to solve for, let's just say, integral of u times dv, so if I leave that by itself on the right-hand side, our left-hand side becomes the following. U times v, and I move this other integral to the right-hand side minus the integral of v du. And there you have it, dear friends, your formula for the integration by parts. I know there are two underneath in the box, but the one that I like to memorize is this one right here. Okay? They both say the same thing. Integral of u dv. So notice I have two things, right? That equals to u times v minus the integral of v du. So bottom line, your strategy here is you need to break up your integral into two parts. So let's look back over here now. If you see how there's the integral of e to the x sine x dx, your job is to break it up into two parts, a u and a dv. And then as we separate this into parts, we then apply the formula to help us find the integral. Okay? The hardest part in this lesson is figuring out which part is which. Which part do you let equal to u, and which part do you let equal to dv? And to help you with that, let's turn the page. So, if you've turned the page with me, the question then once again is, what should u be? U is the part whose derivative is simpler. The goal when you choose u is you should not be getting a more complicated derivative appearing. Okay? dv most likely is the more complicated part, or it's the part that can be easily integrated. Okay? And usually there's only two choices. So if one choice doesn't work out very well, guess what? Just do the other one and try. All right? Now there's also another way of understanding how to choose u, and I've seen this from other teachers. They have this acronym LIATE. Yes, LIATE. When you talk too much, lip it, not zip it. LIATE stands for the following. L stands for logarithms. So I stands for the inverse functions, P stands for polynomials, E is the exponentials, and T is trig. LIATE because this is the order you should be looking at in terms to help you decide what should be equal to u. So if you see a logarithm, let that equal u first. If you don't see a logarithm, then you see an inverse, let the inverse. If you don't see logarithm inverses, then it's polynomials. Don't see all those first three, then it's exponentials. And then finally, your last choice usually for u is trig. Okay? All right, here we go. Let's try this then. Example number 1. See how I'm asking you to integrate e to the x dx? So your job is to break it up into two parts. Using LIATE, do we have a logarithm? Nope. Do we have an inverse? Nope. Do we have a polynomial? Yes. So u should equal to x. And remember, the idea was u is a simple thing to take the derivative of. The derivative of x, of course, is just dx, so that's nice. Or 1 dx if you want. Okay. And then what that means is if x is u, then the rest, the leftover, e to the x dx becomes dv. And if I gave you dv, which is the derivative, and I asked you to find v, which is the integral of that, the integral of e to the x dx is just e to the x. So now that you have your components, now you can use the formula. So remember, the integral of u dv equals to uv minus the integral of v du. You should memorize that. Or you could think, how can I memorize uv minus integration of v du? Some math people in calculus like to call this the ultraviolet. That's UV, right? UV rays. Ultraviolet. And then VDU is voodoo. You scared yet? Ultraviolet voodoo. Ooh, scared yet? So, UV minus V, or an integral of VDU. Back to our example now. So what's U? U in this case is x. What's v? That's e to the x. Minus the integral of v, which is e to the x, times du, which is just 1 dx, or just say dx. Yes, you're still left with another integral, but this integral is much easier to do. And then we can just go ahead and do that. The integral of e to the x, of course, is just e to the x. And don't forget, because this is an indefinite integral, that's right, plus c. And that's it. Ta-da! Okay, let's try example 2. Once again, your choice is what is u? And then what is dv? LIATE, logarithms, nope. Inverse, nope. Polynomial, yes. So once again, u is d or x, and then du is just dx. dv is just everything else then, so sine 3x dx. And now what's the integral of sine? Yes, you say negative cosine. But remember, you have a 3x there, so you have to kind of remove that factor of 3. You can use substitution, or just remember that I have to put a 1/3 in front. Good. So now that you have all your pieces, you're ready to go ahead and plug it in. So once again, ultraviolet voodoo. So here we go, x, uv, negative 1/3 cos 3x minus the integral of v du, negative 1/3 cos 3x times du, which is dx. So simplifying this, negative 1/3 x cos 3x. You see these two negatives here, a negative and a negative. I'll combine them together to be a positive. And what is the integral of, sorry, I will also factor out the 1/3. So now I'm just asking you, what's the integral of cos 3x dx? Oh yes, all those trig derivatives coming back. Integral of cos, of course, is sine. This is sine 3x, but wait, it's a 3x, so yes, 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 yes. Another factor of 1/3 appears in the front. Whew. And finally, we'll have negative 1/3 x cos 3x plus 1/9 sine 3x, and don't forget plus c. Okay. All right. Happy? Getting the hang of it? Yeah, not too bad. Example number 3. Huh, the arc sine. The stuff we did last class. Did you do your homework yet? Don't answer if you said no. Okay, same business, dear friends. Let u equal to something. Let the rest be dv. And magically put it into ultraviolet voodoo and integrate. So this is the integral of arc sine x dx. Okay. Logarithm? Nope. I do see an inverse. So therefore, LIATE says I should be thinking inverse. Inverse, I guess, is the arc sine x. Okay. So you're like, well, Mr. Lee, what's left over then for the dv part? Well, it's just dx. We know from last class the derivative of arc sine is, did you forget already? 1 over the square root of 1 minus x squared dx. So what's the integral of dx then? Well, that just becomes x. So now that you have your components, you are set to go and solve. Here we go. uv, that's arc sine x times x. I'm just going to put the x in front. Or I guess I can put it like this. Looks kind of weird with x and x like that. I'll move it to the front in my next line. Minus the integral of v du. So x times du, which is 1 over the square root of 1 minus x squared dx. Can I write this a little bit nicer and just say x over the square root of 1 minus x squared dx? Now, you are thinking, uh-oh, how in the world do I find the integral of this? Stuff in the bottom, square root. Is it like last day? No, because you have an x on top. I'd say let u equals to 1 minus x squared, because what do you think happens when I take its derivative? You get 2x, and then for dx is equal to du over negative 2. Can you say substitution rule? Sorry, negative 2 over x actually, or negative 2x. Ooh, all this work for the integral. So instead of having x over root 1 minus x squared, we have now x over root u. Instead of having dx, we now have du over negative 2x. Beautiful. X's disappear. I get a factor of negative 1/2 outside. I'm asked to take the integral of a square root in the denominator, which I can rewrite as an exponent, and then go ahead and anti-differentiate. Dun, dun, dun. This becomes u to the 1/2 divided by the new exponent, which is multiplied by 2. So 1/2 times 2 is just negative. So all this work here to show you that this part is just negative square root of 1 minus x squared. Okay? Now, we still have this arc sine x times x in front, so I really should have been continually writing this thing, right? So I guess I'll just go and I'll say here, x arc sine x minus the square root of 1 minus x squared. And then this is an indefinite integral, so don't forget, plus c. Fini. You're like, wow. Yes, so integration by parts can also combine other other integral methods or integration methods. Yes. Calculus is getting scary, isn't it? All this stuff is coming together. All right, 2 more for today. I'll let you try example number 4. Okay. And once again, the hardest part is figuring out u and dv. And then once you've done that, you're on your way because you just plug it into ultraviolet voodoo. Go for it. By the way, that means pause the video, try it, and come back. Be careful when you integrate this. The integral of sine is negative cos, but then you're going to have some numbers in front because of that too. Ultraviolet voodoo. U V minus integration of V du. Half times 2 is just 1. Did you get this? And if you got this, then now you're asking, how do I go ahead and integrate this nasty beast? That's my question too. Substitution. How about integration by parts? Again! Oh, nasty, nasty, nasty. Du equals to dx. dv equals to cos 2x dx. So therefore v equals to 1/2 sine 2x. Alright. And so therefore, looking now just at this part here, I can use ultraviolet voodoo again. So uv, u is x, v is 1/2 sine 2x. uv minus the integration of v du, so 1/2 sine 2x dx. And I guess I should just keep pulling this down because that's still part of my answer. But now that integral has become this part in red. Okay, so one last integral to do. This one I think is not that bad now. I can just take the integral of sine. We know that the integral of sine is negative cosine, so negative cos 2x. Still have the 1/2 in front. There's a 2, so I have another 1/2. Woo! And then if you think about the negative with a negative, that's positive. So this ultimately becomes positive 1/4 cos 2x. And I'll just keep the other things as well. Negative 1/2 x squared cos 2x plus 1/2 x sine 2x plus 1/4 cos 2x, and then don't forget plus c. Now we are done. Wow. Woo! Crazy, crazy, crazy. Okay. Our last example today is one where it's no longer an indefinite integral, so you won't have a plus c in the end. It's a definite integral, which means you're going to have to evaluate it using the fundamental theorem of calculus. More work. That is correct. But the steps are the same. Try to find the antiderivative first, and then at the end, plug in the integration limits. Okay, I'm going to let you try this one yourself as well. Remember, lip it. Lip it. Lip it. let u equals to ln x this time. Du equals to 1 over x. dv equals to x squared dx. So v is x cubed over 3. By the way, if you reverse this, you would have had dv is equal to ln x, and you're going to integrate that, and the answer is good luck. Not happening. Okay. All right. Ultraviolet voodoo, remember? Ultraviolet voodoo, remember? uv ln x, and then an x cubed over 3 minus the integral of v du. v du. I forgot a dx here, didn't I? Thank you. Not too bad. Just simplify a little bit here. X cubed divided by x, that's x squared. So 1/3 I'm going to pull out. That's not bad. I know how to find the integral of x squared. That's just x cubed over 3. So x cubed over 3 natural log x minus 1/3. Guess that's 1/9. And then once you've actually got the integral completed, now you have to evaluate from 1 to e. I really should be doing that throughout here, so my notation is proper. 1 to e, 1 to e, 1 to e, 1 to e. And then now let's go ahead and evaluate. So I'll plug in e first of all. That's e cubed over 3 times ln of e minus e cubed over 9. Then we'll subtract from that 1, so that's 1/3 ln of 1 minus 1/9 times 1 cubed. Ln of e is just 1, so this becomes e cubed over 3 minus e to the power cubed over 9. Ln 1 is 0, and so negative and a negative is a positive. That's my answer for number 5. I think you've seen enough. It's time for you to try. Have fun with the assignment, everybody. See you next time.